Thank you. Thank you. Welcome. Yeah, so I'm Nicolai Parlog. I'm a Java developer advocate at Oracle. But enough about me. It's going to be about modern Java in action today. And I brought a lot for you. We'll implement a small GitHub crawler, although it's not small enough to code everything here, so we'll occasionally get some support from Git, which is my old man version of AI. We'll aggressively use, abuse, and overuse modern Java features. Not everything is meant to be. I will do it exactly like this in my production project. There's a lot of just to get inspiration. Also, I will not have time to explain basically any of the features that I use, because there are too many. On Monday morning, we gave a 3-hour session that went over these features and just a few more. So either you know those features and you're like, yeah, I know what he's doing, or maybe you don't know one feature or the other, and you'll take away that this is worth looking into. You can go to the Java YouTube channel, and you will find introductions on all of this in a lot of detail. And you can also find shorter versions from Billy, for example. He does this zip-off Javas. So a lot of content there to catch up on if you want to. The code I'm showing you here is online. Go to my GitHub, and then it's Modern Java Demo. It's kind of close to the title of the talk here. So I hope you'll find it. The slides are also already online, although they're very minimal. So I'm not sure they're going to help you too much, just for completeness sake. And if you have questions, you can ask them at any time. I know this is not easy for those of you sitting further out, but if you have a question, if I make a mistake, if you think you can fix it, just yell loud enough so I can hear you. That's perfectly fine. Okay, let's start talking about the GitHub crawler. We're going to do something comparatively simple. We're going to connect to a URL. We're going to identify what kind of page that is an issue page or pull request page. We're going to identify the interesting section, but that is going to be some of the code that we just check out because that's a little bit boring. Then we're going to identify the outgoing links. Same, that's going to be done already. And then we're going to start over and go through the links and find more pages. And when we hit an external page, we're just going to stop. We're not going to crawl, also Wikipedia. And then if we do all that, we're going to print some statistics. We're going to print a little page list. But most importantly, we're going to show the result on localhost as a very simple website. So this is an example for something that you would draw up as a hobby project for yourself, or maybe to get an overview of a project. This is not meant to be run in production for customers. It's just something that you would maybe build for yourself. For the domain model, we're going to use records and sealed interfaces to model the kinds of pages that we'll be seeing, and we're operating on them for these operations with pattern matching. So we're going to switch over the pages. We're going to have a bunch of cases for each individual subtype, and we're going to process them there. To fetch the pages, we're going to use the HTTP client. I just deleted the word new there. It's since Java 11, so it's like 5 years old at this point. So it's just the HTTP client that's on board. And we're going to use virtual threads via structure concurrency to fetch all these pages in parallel without having to care about how many threads we really have. Now, it doesn't make a difference because we're not going to request thousands and thousands of pages at the same time. But you could imagine if that were the case, how this could help. We'll present the results with text blocks and string templates, and we're also going to host a simple file server that's also included in Java since 19, I think. And just for fun, we're going to add some modules because they're always good. And with that, I want to get started with the code. So this is the project as we start out. It doesn't contain very much, so let's start with the domain model. We're going to have a record for external pages. Let's just start with that. And an external page is very simple. Oh yeah, by the way, I'm a terrible typist. You will see me typo a lot. I ask for your forgiveness in advance. So this external page will just have a URL and some content that we fetched. And we could be done with the record already, but let's do at least a little bit. And let's make sure that what we get makes sense, right? So you want to validate at the boundary, that this would be the boundary where we get the data. We want to validate that what we get makes sense and is fulfilling all the rules that we put onto our domain. In this case, we also want to make sure that the content isn't empty. Okay, so if it's blank, if it is blank, we're going to throw a new illegal argument exception, and we're going to put a good message here later. Let's say to do for Copilot. There we go. Okay. So as you see, I learned a lot at the conference here already. Great, yeah, so what we also want to do is, this gets an equals and a hashcode function that uses both the URL and the content. Given that the URL starts with the U that stands for unique, you could maybe consider creating equals and hashcode that use just the URL and not also the content. So we can override all of these methods that are in a record. That's good. We can also do something a little bit fancier than this, though. Look, we can say return. Well, we can do this check in the beginning. It's not terribly important, but let's do the check in the beginning. And otherwise, we can see whether O is an instance of also an external page. And if it is, we're going to turn it to a page. And we're going to say, and I'm going to take this stuff, page.url. So what we're using here is type pattern matching. We're going to rely on record being final, so this is definitely safe. Very, very short version to write an equals method. I really hope that we're going to get support from this from our IDE soon. OK, let's do that's something a little bit more involved. Let's have another record. That will be for the GitHub pull request page, because we're also going to fetch pull request pages, right? I think that's the name I'm supposed to give it. Going to have a few of the same types. It also has a URL. It also has content. But what this one has is, because for GitHub pages we also look for outgoing links, it's going to have a set of links. And for now, and this is going to change later, we're going to save these as URIs. And also an issue number, of course. Oh, no, PR number, sorry. So again, we can create a compact constructor, and we do some verification here, which I'm going to skip. But what we can also do, and what we should do in many cases, is we should consider records as being treating data as immutable data. So I want to make sure that the links, for example, that we get and that we return with the links accessor is actually immutable. So we're going to create a copy of it that's an immutable copy. And if we are given an immutable copy, this is a no-op, so that's good. So it's not very wasteful. And this way we do create a copy, though, if it's necessary. And because I already know that later I'm going to need a constructor that does not have links yet, let's create that one as well. So in a record, you can also add additional constructors as to your need. This is terrible, of course. So let's put an empty set here. We can also do we should actually do the equals and hash code based on URL, but I'm going to skip that here. There are 2 more records to create. I'm not going to bore you with that. So instead, we're going to check out that solution. That's this. We now have all 4 records that we need. These are the basic types. When we connect, we can either get an error, or we can get an external page, or one of these 2 GitHub pages, because we're going to pretend GitHub has no other pages for now. OK, I just said if you try to connect, it's either this or that. And if it's that, if it's successful, it might be this or that. We can express that, and we should express that. That's part of this concept of data-oriented programming, to express these relationships as well. So we're going to create a sealed page interface, and we're going to make sure that only specific types are allowed to be a page. Specifically, we're going to have either an error. Great, that's already there. Or we can have a successful page. There we go. And all pages, I think this is the time to define a little bit of a contract. All pages have a URL. Good. Now we get a compile error because successful page doesn't exist. Let's fix that. Let's create a sealed interface successful page. And if it's a successful connection, what can it be? It can either be an external page, or it can be a GitHub page. Also, notice now you're probably picking up the clicking of the keyboard, which is kind of fun. All pages that we successfully connected to have content, so that's good. Now let's keep going. Let's create the last interface, I promise. Let's have a GitHub page interface. Oh, that was one too many. And this one permits the two records that we have. Good. So now, what can they have? So first of all, they're going to get the links that I mentioned earlier. But we no longer have to turn it as a set of URIs. Instead, I want to return as a set of pages. So I want to resolve the URIs, and then each page knows the other page that it's being linked to. The new types don't fulfill that yet, but we're going to fix that in a second. I also need another method that I'm not going to go through implementing, so I'm going to copy-paste. I'm going to start copy-pasting a bit. This one is, let's just look at the header here. It's a subtree function, so starting at a page, it will give you a stream of all the children of that part of the tree. Technically, it's a graph. We have back references, but we're going to treat it as a tree a lot of the times. So this is all this does. It's just some mechanics to put everything into the array list and then stream the content of that array list. That's all it does. What it does do, though, it uses sequence collections. It uses remove first, which you can have on a linked hash set, for example. And here it uses reversed, which allows you to easily flip the order of a sequence collection. And this is not necessary here, the reversed. You could even also remove last. You just get the results in a different order. And this makes a little bit more sense, but it's not essential. OK, now let's go fix these thingies. Let's make this implement this interface. So now we implement GitHub page. And GitHub page inherits from all the other interfaces that I declared. And I declared the contract in a way that the record accessors fulfill them. So for the component URL, you get an accessor URL, opening, closing parenthesis, which is exactly what GitHub page requires us to have, right? So this is implemented by this. And then this implements content. This is broken, though. This should be a set of page. And due to the compact constructor not referencing those types, I don't need to change anything more. Let's keep going. Sure, let's go here. We implement this. We have this one. Same fix here. And now successful page. There's one more. Where is it? There's one more compile error. Come on. Ah, there we are. Sorry? Yeah, I don't think I need to. I think it's good now. I think it's good. Right. So those are the sealed types on top of those records. So we use the records to model the data as closely as possible, and then we can use sealed interfaces on top of them. Doesn't have to be on top. They could also that you've seen that here actually. Some page references the interface page, but then you build a hierarchy of types that is sealed from top to bottom. So you know when you have a page instance, it must be one of those 4 records, and we're going to lean on that heavily later. OK, so let's do what I just did again. Let's kill what we just programmed, and let's check out the good version, just in case I made a mistake. And now this is one is a little bit of a bigger step. We need to fix quite a few things. Let's look into the crawler package. We have a page factory and a page tree factory. The page factory gets an individual page, identifies what kind of page it is, and then makes sure that it finds not the header and not the footer of the page, but the interesting section and pulls out more links. All of that is already implemented. Doing that is kind of boring. I'm a little bit ashamed to say that I used something from Swing to do it, even though I later do use JSoup, so that's something I would fix probably. But here I want to show you something that happens occasionally. You occasionally have a situation where you need a type to just quickly put 2 things together. And this is what records are really great for as well. So let's create a record just for this. Yes, in the same package. We don't need it to be public. It's package local. And what this one is, it's really simple. It's really just a page with links. But these kinds of pages, I will use them at the point where I have identified the page, but I have not identified the references yet. So I need a mutable version of this that I can do this with. So here we're going to have the set of URIs, actually. Those will be the outgoing links. And here it is important that these outgoing links are mutable. I want to add them. So like records want you to treat stuff immutably, but it's OK if you make a conscious exception. You say like, nope, in this case, I need something else. So in this case, I do need something else, because I want to have a page with links where the page is already done, but I still need to add links to the set, and then later I can resolve each link in that set to another page, and then I can put together the final page, which is all immutable. OK, so let's create a new hash set here as a copy. And I already know that I need later one that is just the page with the empty set. Again, this one passes null, which is terrible. So let's do this. Oh, right, sorry, this is broken. Need to create the mutable copy. Good. That's this one that takes care of this first compile error. You can see there are a bunch more. And this all relates to the Swing stuff for the HTML parsing that I mentioned earlier. I do import it, though. So what's up? Where are the mistakes coming from? We're using modules, remember? And that means I must actually declare the dependency. So let's make sure that I say that, yes, I'm using Java Desktop, and that takes care of all of that. Although there are a few more things that we need to fix in this class later. Before we get there, let's quickly finish the module system stuff. Here we're using the HTTP client, also a module. Like, I'm not even sure, maybe IntelliJ actually knows this. Let's try. Let's experiment during the live coding. Sure, what can possibly go wrong? Oh yeah, it does. See, there you go. IntelliJ does it for me. And here we are with the requires clause. Okay, now let's go back to the page factory and let's fix other errors that we have in here. I left some to-dos. Okay, right. So what's happening here is I have this parse method down here, and it needs a specific parser. So for example, I can call this with parse, and then I can give it a new issue page parser that takes the URL and takes the HTML, and that returns then a page with links. So that's implemented somewhere down here, right? And that's the part that we're going to ignore for now. But I have to pick this parser based on the URL. So you would think I could just write an if, right? If the URL says issues, do this. If the URL includes PR, but this, and then here we come to the use, abuse, and overuse new features. No, we're not going to do that. We're going to create a parser. We're going to switch over the URL. I'm going to say, so in case the URL is a URL, which is kind of redundant, but bear with me, and the path, oh, wait, this is, oh, sorry, URI. I call them URL, but I use the type URI because it's not as broken as the URL type. Oh, my colleagues here are working on these libraries. Victor, I didn't say that just now. Good. Let's see whether this one contains issues. And if it does, then we're going to return a new issue page parser with this URL. I mean, we could put U here, but it doesn't really matter. And that's that. And now we get a compile error, and we get a compile error because the compiler knows that, wait a moment. I mean, I know that the URL is of this type, but this is a condition. If the condition isn't fulfilled, then what's the result? So we have to make sure that we cover all cases. URI is not sealed if you're making a connection to what I talk in other places. Like, this is not a sealed type. It's just a regular type. It still needs to be complete, though. So let's quickly cover the other case for the PR page parser. And then we're just going to put a regular one at the bottom. This is basically a catch-all. It's like a default. Because we already know it's a URI, case URI will capture all remaining cases. And this will be the external page parser, I hope. Parser. There we go. OK. And that's all that. And right. And now we have the parser that we need. And now we can put that one here. And just for my future self, right? Just to threaten myself, this is better. Switch is better than if. OK, I hope you know that I'm, sometimes joking when I say these things. I'm not going to tell you what times. You have to think through it yourself. OK, that is the page factory. Let me quickly take a look at all of these nodes that I have here to make sure I don't miss anything. Oh, wait, no, I don't even have to look that up. I know that there are more to-dos here. Oh, those are the to-dos for better implementation. We have more to-dos here, right. So now let's get a little bit more into the networking stuff. We're now going to figure out how do we connect to the URL, how do we fetch the content, and then also how do we do that in this multi-threaded way that I alluded to earlier. Let's start. Let's start here. Let's create and send an HTTP request. So as you've seen up here, we do have an HTTP client. I'm going to show you, what, let's start there. Let's start, how do I get a HTTP client? HTTP client. This is the main class. It doesn't do much at the moment. Let's create a client. By the way, if you don't like my overuse of var, that definitely also goes into, at least some of it, into the abuse portion. There are cases where I use var here, where you should really put a type to make it more understandable for the people reading your code. OK, so HTTP client. We get a new builder, and now I have a ton of options. Connection timeout, authenticator, cookie handler. I can set all kinds of things here. I don't need any of that. I'm just going to call build. I'm even going to go one step further and just call new HTTP client here. At this point, IntelliJ is complaining that the HTTP client is auto-closable. I should be using it in a try with resources block. Because it's a demo, I'm not gonna. But that's good to do in general when you're writing production code. OK, let's create the factory. New page tree factory with this client. Oh, sorry, with the client. And then, I mean, it's not working yet, but soon it will be working. Let's create the factory. And look what I'm doing here. I have created a little record, a little local record. And I'm parsing the command line arguments to the record. I'm doing this here manually in a super short piece of code. so it remains like short and readable. But you can create an engine from this, which is really, really cool, because this is easily accessible via reflection, even without anything like breaking into types. You can easily have a library, because I wrote like 80% of it, that takes a record class and then goes to the args array and tries to figure out, oh, the record has a component called depth. Is there a flag depth that I can then map? Oh, it's an int. Can I do integer value of? That's really cool. Like it's that makes it really, really good to have to do something like this, where you get in the args array and get back the record with just the parsed stuff, not as strings, but as the domain types you want to use. Okay, so let's create the page. We need here the seed URL, the first URL to start with. We're going to use, see, there we go with the typing, config.seedURL. There we are, okay. And then here we're going to use the depth. Oh, and since we're here already, I want to print that later. So let's, this will be the root page, meaning the first page I contacted to, but it has as links to the page that it links to, and so on and so forth. Let's link this. Okay, this is not going to work because of all the to-dos that are still missing here. We were busy with the HTTP client. We just created that one, so now let's use it. The way you use the client, basically, is to say client, and then send. You send a request. We still need that one, though. And then you need to define how you want to handle the return, return body. Specifically, I want to turn the return body into a string. This is pretty cool. You can have a body handler that turns the string immediately into a user instance, for example, if you want to. Then return the body. Now, this is a blocking call, right? This send here is blocking, throws interrupted exception. So this is clearly for virtual threads, for fully blocking code. Let's create the request. The request is very similar to the client. You go to HTTP request, you get a new builder, and then here you can define all kinds of things. You can override which HTTP protocol you want to use and all of that, or which version rather you want to use. I'm just going to get, we need to pass the URL though. I don't need the get, by the way. I just kind of like to do it. I like to see the HTTP operation in this request building. It's not necessary though, just for my personal taste. Okay, so that's good. So that was how to create a client and how to create the request for it, both in super simplified forms, obviously. Let's now do this with the virtual threads, since we've been talking about blocking. Okay, so what we basically want to do is we get these links here. Here, we get these links. And what we essentially want to do is we want to say links, and then for each, we get the link, and please do create page call with that link and the depth. And then I just now realize somewhere up here, somewhere I need to add a -1. So the depth is there, so we don't crawl like literally all of GitHub. And if I don't put the -1 there, that could potentially happen. I forgot where it goes though. But I think the specific issue I'm starting here with doesn't link to all of GitHub, so it's good. We just keep going. Let's ignore this for now. This is what I really want to do. For each link, create a page for that link. Like, this doesn't even compile yet, but if I would do this, I would then do the first one and block and wait for the first request, and then the second one and the next one. And obviously, we don't want to do that. We want to wait for all of them at the same time to increase our chances of GitHub blocking this IP, which would be fun during the talk. So let's do virtual threads with structured concurrency. We want to create a scope. We want to create a new structured task scope, and specifically, we're going to create one that shuts down on failure. That means if one of the threads fails, the whole thing will be shut down. Let's not do this. Now, this is not supposed to happen because we have this error page type. So every error that occurs during like fetching or parsing should be mapped into that error page type. But still, that makes the most sense here to use that type. Okay, and now we're going to not do this. Instead, we're going to say for each link, take the link. Oh, well, we have to do stream then, right? Take the link and then go to the scope and fork a new task. And this task will run in a new virtual thread. And then create the page there. How many? Yes, that looks good. Turn this into a list for reasons I'm going to explain shortly. Because, oh, crap. Yes, introduce local variable. Because this will be our tasks. So now we fired off all those tasks. That happens basically immediately. Virtual threads will now launch and will do their thing. If there are like a gazillion virtual threads, some of them have to wait for the platform threads to be ready to handle them. So we need to wait, and we're going to do a scope join for that. And then it's very good practice, actually it's terrible not to do that, to throw a failed right after. That one throws an exception if this happens, for example, right? So this is there to make sure that if anything happened in that scope, we throw the exception here. And that also shows you strength of structured concurrency, because that means that the error handling happens in this one place for this level of concurrency that we're starting here. Okay, when we're done, I want to take our tasks, and then we're going to call stream, and then we're going to have to take stuff out of the subtask. We're going to get the results, and we're going to turn them into a set. There's that. Good. Now all we need is to catch this exception, and here comes into play what I said earlier. This should not happen. Shouldn't happen because of error page. So error page should have caught all of these. If this happens, it's not a bug in the connection to GitHub. This would be a bug in the code that I wrote. Okay, and that's the structure concurrency portion of the talk. So if you have any interest in the virtual threads part or the structure concurrency part, you could now ask a question, or later, I'll be here. I wanted to fly home soon after the talk because I got to be home tomorrow, but Lufthansa told me that's not possible. It wants me to stay here till tomorrow morning. So I'll be there all day if you have any more questions. Okay, one thing that I forgot earlier is this. We have to create a copy of the resolved links. So what's going on here? This is further up in the stack. I told you about this page with links dance. I first create the page and a set of the URIs of outgoing links, and then I resolve those. And that's essentially what's happening here. I get a page with links instance here. I now have a page, and I now want to resolve the links. So essentially, I want to say, what was it called? Resolve links, I think even? Yes, resolve links. And then I want to take the page that I'm getting here. I want to say page.links. And that's not working. Anybody knows why this is not working? Oh, this is where depth -1 goes, by the way. Why is it not working? Why can I not call links on page? Didn't define it, right? Because not every page has links. External pages don't have links because I don't want to track those. And error pages don't have links because I couldn't connect to the page. So they could return an empty set. But this is what I mean when I say that model the data as closely as possible with records. Yes, I could make the error page return an empty set of links. But it doesn't really make sense. It kind of works. You could argue that it's somewhat logical, but I think it would be better to not have that method there because it doesn't apply to that type. So we have to do some more instance of doing here. So let's return the result of a switch. We're going to switch over the page. And we're now going to say, in case it's, let's start with these, error page, or what's the other one? External page. Then we're just going to return the page as is. We're not going to make any changes. But if we find a GitHub issue page, and what I would really want to do now is this. I want to say the issue as it is, exactly as it is, with the property links set to resolve links. Now, this is very red right now, and will stay very red for a while longer, but this is a fix, or this is a change that is on the horizon, where the Java language will take apart the record, will reassign this one variable, and will then recreate the record, but we're not there yet, so we have to find another fix. So I'm going to do something else because I didn't do it yet, mainly. Let's take this apart. Let's split this up into the URL, but I think I already used that variable name, so I'm going to call it URI. Into the content. I don't care about the links here, so I'm going to use the underscore. And then we have the number here. And so now I have to recreate it manually. This is basically what this with construct will do for me. This exact thing where I have to manually take something apart and put it back together. Var content, this is where the resolve links comes in. And now I think the number is missing, and this should be right, except this is not links, but page with links. Okay, good. Oh, right, we have to do the same thing for the pull request page. GitHub PR page, new GitHub PR page. Okay, this should do it. Actually, we can try. Let's run this. So I've run this before. I already defined some seed URL. It's for an open source project that I'm doing. And oh, the connection here is better than in the hotel. It took way longer there. So this is the result. This is the toString of the GitHub issue page record. And because the toString includes its children, it's a pretty long string. It includes basically all the children it found. That's good to know that it works, but it's kind of terrible to look at. So what we're now going to do is we're going to work on making that a little bit better, a little bit prettier. First step there is we can go here and make sure that this is not like that crowded, like right down here between these other messages. And one decent way to do this would be to turn this into a text block. So let's do that. Let's turn this into a text block. We're going to have one empty line. We're going to put a divider here. And here we're going to put root page. Oh, no, wait, that doesn't work. We have to reference it as a variable. No? If this was an Apple presentation, there would be roaring applause by now. OK, anyway, so this is string interpolation in Java. Yeah, exactly. Woo! Right, we're going to use it in a little bit more in depth in a second. Let's redo the step where I kill everything I just wrote to make sure there are no mistakes and start over for the next step. OK, so the next step we're going to do is we're going to implement one of our operations. We wanted to do statistics. We're not going to have time for statistics. Those are boring anyway. We're going to do the pretty printing. That's nice. OK, let's do pretty printing. The method I'm most interested in just gives me a page name. Public static. Oh, dope. Static. OK, let's try over. Static string page name. And this is classic data-oriented programming now. Given a page, do something depending on the type. I could put a pretty print method onto the records. And that would even make sense in this specific instance because it only uses data from the record. It uses no external state. This method would be perfectly fine to put on the record. But it's a simple enough operation that I can quickly demo it here. But more complex operations you would not want to put on the record. You would want to put into an external class like here. And this is what I'm going to demonstrate now. So this, I'm going to put it in an external type. But that means I need to know the details of the record. And I'm going to use, again, pattern matching and deconstruction patterns for that. OK, so return switch page. And now here, let's say we have a GitHub issue page. There we go. And what we're interested in here is not the URL, and this was the content also not, and not the kids either, or the children. I want to only include the number. And I want to map that to what? We can write issue number. Or we can do what we just learned, and IntelliJ so helpfully suggests let's use a string template. This made it longer, but still it's cool. Like there's one edge case where string templates don't make sense, and that's when the variable is at the beginning or at the end. Because then the string template does make it longer. But as soon as you have more stuff here, then the fix makes it shorter and more readable. OK. Now I could type out the other versions, but that would be somewhat boring. And I know you're already bored by this talk because I'm talking so slowly. So let's do something else instead. Let's copy paste this. This also has emojis, which has an added benefit. Right. So now we need to do some imports. There we go. OK. So I'm doing the same thing over and over. I'm destructuring. First, I'm switching over the type, picking the right type, destructuring into the components, using underscore for all the components I don't care about, and then using the remaining components to create a result on the right-hand side. And I would argue that this is supremely readable. You can see on the left-hand side what I care about. I care about external page, or specifically just about the URL. On the right-hand side, you can see what happens with this. So if you're looking for a bug or for a place to put your feature, you can scan the left side and see what's getting pulled out here. And the right-hand side, you would see what's being done based on that. OK, that's good. I also want to have a list, though. So let's have a page list. That's actually just regular Java Stream API. I want to say page.links and then .stream. And oh, no, it's the same problem again. It only works for a GitHub page, right? Only GitHub pages have this property. So I'm doing the same trick again. I'm asking in a slightly different way. I'm asking is page an instance of GitHub page. And then gh page, I put that here. And then I get this variable. There we go. And then I get this variable. I can map with pretty page name. There it is. And then we join this with a new line. So every issue gets a new line. And what's this complaint? Oh, yeah, right. It wants me to indent this, right? And also, we're only returning in the one case. So what I could do now is I could write an else path for the other case. But this is kind of like an early return. What I actually want to say is, in case I'm in this weird edge case where it's some other kind of page that doesn't have children, I want to abandon early, right? That's what you often do at the beginning of a method. And we can totally do that. So we can put a no here, and then we say, OK, if it's not a GitHub page, then we're just going to return the page name of that page. And otherwise, we can use gh page. Now, how can I use gh page here with the negation here and the early return? I'm going to leave that for you to dream about tonight. But it does work. And you can maybe tell that I don't write code that any colleagues really have to read and understand and work with. OK, that's that. Let me think. I think we're already done with this part. We're just going to put it into the GitHub crawler somewhere. Here, now we can pretty print this. That was going to be very good. Pretty page name. Oh, sorry, page list. For the root page. Let's run it again. And now we should see something a little bit nicer. All right, by the way, the messages here, they sometimes say found cached. So these are just the log messages. I wrote just system out printf is what I used for them. Found cached means, issue A links to B, B links to C, and then later A also links to C. I'm not going to go to fetch C twice. That's just what that means. That all happens in the thing that we checked out. But here, that's the output. There we go. Now we got emoji list output for our for whatever we're linking to. So there's apparently links to GitHub, to documentation. There's links to other issues. No links to pull request. I'm somewhat surprised to notice. So yeah, that's that part. Let's do that mean trick again. And let's do the finales, which will be revolving around string templates. OK, so we have a new type here. Oh, also we have the statistician now who does statistics, but it's not that important. Let's look at the result server. The result server wants to do two things. It wants to create an HTML file, and it also wants to start a server on that HTML file. Now, if you look at creating HTML in Java as strings and want to get up and leave, I get that. But we're going to make it better. But first, let's make it work at all, because this just doesn't have any specific information. And I already showed you this trick. We're going to use string templates for that. String templates for that. We're going to put the page name here of the root page. Yes. Then we have to put an str here. And down here, we can call a method that's called pageTreeHTML. PageTreeHTML, we give this the root page. And it does a few back and forth, like going through that tree and creating individual diffs for everything. And you'll eventually end up here in this method. This is supposed to be the diff for an individual page. But at the moment, it's also static. Let's make sure it includes the information that we want. So this needs to be the level. This is the level of depth from the root page, which will also end up to be the level of indentation. So there's a CSS class for that. Here we're gonna put the page URL. For once, we don't have to do pattern matching, fortunately, because all pages have a URL, right? And as text, we can again use pretty to get a pretty page name for the page. Now here's a little bit of an extra. I pass in whether it's a reference. Again, one page can be referenced from two other pages. And I don't want to repeat the whole tree every time, right? But I want to make sure that the reason why this, it's like made like a Maven dependency tree. It's cut off at some point. But unlike Maven, I want to point out, look up, you will find the longer version upstairs. So I'll just say, is this a reference? And if yes, I'm going to put in a span. So you can see, you can nest this, right? You can also nest string templates and other string templates. I'm pretty sure that there's a cutoff point where this starts becoming unreadable. But also, if you do it well, it does kind of fit together naturally, the sections which are just text and the sections which are more dynamic. Let's call this ref and close this span. And there's that. Look, GitHub is not, IntelliJ is not quite catching up here. Like, huh? This is green. It's not supposed to be green. OK, that should be that. I think it almost does the trick. There's an import broken. What was that about? Oh, right, yeah. So the classes that reference the simple web server that I'm not yet using, there are already, the import's already there, so that's why the imports were faulty. Okay, but that aside, I think this should now work. We can go back to the crawler. Let me check the time. I have some slides at the end, but those are optional, so let's keep doing this instead. Right, and the result server is gonna launch as well already. So I think what we should see here is not an actual server, because we didn't start the server yet, we didn't do that. What we should see instead is at least this index.html file. So let's have a look. Serve here, great. The style CSS is something that I wrote before, and then we have this here, which looks like it contains some content. Not a lot, to be honest. Level 3, oh no, okay. I was expecting a bit more, but whatever. Looks a little broken, right? A lot of empty lines here. I'm gonna fix that in a second. What we can also do already is, we can go into that directory, and we can start JWebServer on a port, let's say 8080. And now this is JWebServer, comes with Java. It's just an onboard tool. This is the tab, and if I hit F5, there we go. That's what we. Thank you, chat, and everybody else. Right, so this is the JWebServer that we just launched on the terminal. But you don't want to always do that, right? You don't want to go to the terminal and then launch that thing. So let's do this programmatically within our system. Oh wait, Control 2 doesn't work here. That's Control C. This is Control 2. Okay, let's do this manually. And for time's sake, automatically as part of our system here. And to make it a little bit quicker, I'm gonna just steal this code. And I'm gonna explain to you what it does after I pasted it. So we're gonna go here, we created that. Now we have a method here, and we're gonna call that launch web server in new thread. We're gonna pass it the directory. So this part is just a little bit of song and dance. The important part is this. There's now a class called simple file server. It is simple intentionally. It's not meant for production use. It's meant for testing, for demos, for personal use, stuff like that. What I'm really doing here is use this port, use this directory, give me these messages, and off you go. And because that starts a thread that blocks, I'm putting that into a separate thread, and I want to have a nice message on the terminal to make sure that I, recall where I have to go. So now if we go here, we'll print at some point visit localhost 8080, which again is the same page. Oh, look, it reordered. But hey, that's a set, right? No stable iteration order. Also, we don't know at what times GitHub returns stuff, so that's where the instability comes from. Oh, and you can see the little arrow here as well, by the way. Okay. Now, what's left is getting rid of this ugly HTML stuff. What we really want with string templates is to not use str, because str doesn't know anything about HTML. It will not escape anything, it will not check anything, it will not check syntax. This is the worst way to use string templates. We want to have a specific one that knows about HTML. So let's implement that. Let's say util HTML is going to be our new class. And what we have, I'm going to put this, implement this as a private inner class. Private static class JSoup HTML processor. And it will implement, let's close this, implement the string template processor type. And will return not a string, but a document. All right, for this to work, I need to add JSoup. Oh, org JSoup, there we go. It's going to return a document. It could return a string, but this is also really cool. It can return an intelligent domain object instead of just a string. Now, there's probably a good way to implement this that goes deep into JSoup and makes sure that, for example, the strings that are put in cannot actually contain HTML itself, because at the moment they can. The string portions I put in, or the variable portions I put in, can contain strings, can contain string that are HTML, and thus inject HTML, which I might not want to do. I might want to make sure that this is escaped or quoted. I'm not going to do that, though, because I'm not actually a JSoup expert at all. So I'm just going to ask JSoup to parse the interpolated string template. Right? So this is the dumb way to do it. But it already has some benefits. And now we're going to create a public. This is also very common with string templates. you will have a public static final instance. If there's no state related to it, it will just do something like this. HTML is the new JSoup HTML processor. There's that. Oh, new. Just otherwise I can't sleep tonight. Okay, good. And this does the thing now. Import static constant, there we are. Now we got a compile error down here because it's no longer a string. We have to attach it to string because this, what we get back now, is actually of the type document. So if you want to do anything with that, like ask it for children or do something like a jQuery, we can do all of that here now because it's a smart domain object. Okay, with all that said, we should now run this. When we look back at index.html, it will also be better formatted. Right, so this is a little better formatted because JSoup just formatted it. Also, in my original HTML code that I just wrote as a string, I didn't put the backslash here and I had like opening and another opening div, but JSoup caught that and turned it into an opening and a closing div. So that works really well. Okay, there we go. A little bit of instability again. But yeah, that's that. Now we got a little bit of time to go through the remaining slides. Okay, so let's catch a breath. You can tell I was worried I wouldn't get through with everything. For the domain model, we used two different approaches, or two different things that work well together. One was we used sealed interfaces to make sure we can model this or that situations, like we did with page. Then we created records like GitHub PR page, which implement these interfaces and that contain, the data that we need as closely as possible. We did argument validation. We created helper constructors where we needed them. We overrode equals and hash code to match the behavior that we want. All of that is possible with the records. Yes, you can define a record in one line and just like page with links that might do the trick, and that's cool. But you can also customize what you need to be customized. We created this little inheritance hierarchy. And the interesting thing about this is that every type here is either sealed or final. And that means when you have a page, as I mentioned a couple of times, and we applied throughout the live coding, we know it must be one of those other types, right? If I have a page, it could be an error page or a successful page, or it could be an error page or an external page or a GitHub page, or it could be one of these orange ones, right? And that's really valuable. That's important for the compiler. It's important for us to write maintainable code. Then for operations, we did these switches. What I didn't go over is, if we add a fifth element here, fifth kind of type here, fifth kind of page, sorry, and we also expand the permits clauses to allow that, we would get compile errors here. All of these switches would suddenly not compile anymore because we don't cover all cases, which is what you'd want. It's like the visitor pattern without the pain. You can immediately go to the operations that need updating when you add a new type. We use the HTTP client in a very simple form here, but you can pass all kinds of arguments to it. You can also use it asynchronously, by the way. Then it returns completable futures, if I'm not mistaken. So there's a lot more power hidden in the HTTP client here than what I've been showing. So I would claim that for many projects, there's no need to have an external library. Okay, we use structure and concurrency, surely the most complicated code block I wrote to you earlier today. This is actually an old version where I still did a for loop for whatever reason, because I think the fork used to throw in the past. Let's ignore that. It has always three sections. The first one is, for every task you want to do, you want to fork. You want to join and throw if failed. And at the end, you want to fetch your results. I mean, arguably, the fourth part is handle exceptions, which if you don't encode them in the return type, you really have to do diligently. We use string templates. We did some just inline HTML and wrote that in a Java as a string. I'm really waiting for IDEs to pick this up, for them to see, oh wait, I know this template processor. This template processor does SQL or JSON or HTML. Let me helpfully highlight this language in that syntax, and then also give you code completion, for example. That's how we implemented the JSoup HTML processor, which was here very, very simple. A real one would be much more involved, would probably parse incrementally, would make sure to properly handle variables that are passed in. Use a simple file server, again, super straightforward, handy tool. We didn't use JPackage, which I promised, and the reason being is that my Linux distribution does not actually support RPM or dep. So that's a problem. So we have a few things here. I'm running out of time, so I'm going to leave this with you. Here, Jose is creating an exe file on Windows. He's installing it. He's very happy about it. here he's doing file association. Just as another example that what you can do, he's associating all JPEGs that have the .duke extension with the program that he wrote, and then you get, this little icon here in your file browser, and if you click it, you will open with this app. And that's it from me. If this kind of stuff interests you, please go to youtube.com/Java. We also have dev.java and inside.java to cover all your needs of whether you want to learn how features work or you want to observe how Java develops. Thank you very much.